Well, guys, this is the fourth part of vector calculus, and today we will talk about directional derivatives. What is directional derivative? If you know what is gradient, then you can understand directional derivative. Otherwise, it is a little bit difficult for you. So, however, first of all, we know that gradient, the magnitude of gradient, is giving us the maximum rate of change of a level surface on the perpendicular direction, right? In directional derivative, we just have to calculate the gradient, the projection of the gradient at another direction, which is, let's say, m vector. Well, now how can we find out? It's very simple. We have to do the dot product between g vector and the directional vector, which is nothing but the unit vector of m, right? We have to do the dot product and we will get us kind of like g cos theta, okay, mod of g. So something like that we will get. It's very easy to understand, right? So this is the directional derivative. Now how we can calculate the maximum directional derivative? For maximum we have to understand something like for maximum cos theta, the term cos theta will be positive one. So dd max, dd means directional derivative, dd max is nothing but the magnitude of gradient, right? The magnitude of gradient. Hopefully you can understand what I mean. Now the most important thing here is, let's say I am talking about two vectors, let's say a vector and this is b vector. Both are parallel and the direction of a vector and b vector are same. It is the only possible case where we can say that a dot b will be max. So for dd max, be careful, for dd max the directional vector of gradient or unit vector of gradient is equals to unit vector of m. M means the second vector, right? So this is the condition you need to remember. Hopefully you can understand, and this is the main condition, okay? Sometimes maybe you have to solve a kind of equation which is very hard. In that case, this statement will convert the equation into a very easy equation actually. So this is about directional derivative. Now let's say I'm taking an example. Let's say this is x cube y plus y square z plus z, let's say, and this is the, let's say, level surface, okay? This is the level surface. Now we have to find out the gradient and we have to find out the directional derivative at a point, let's say p, and p is 1 comma 1 comma 1. You can take it like you can take p like 7 by 2, 9, 99.9, something like that you can take, but definitely I will not take because I am not genius. My calculation speed is too much damn, and calculation is too much damn, so you know what I mean. So I will take a simple uh, assumptions, however. So in that case, how we can deal with such kind of questions? We need to find out the gradient first. And another thing, which is m vector is given as something like let's say, just assume uh, I3 I cap plus 2 j cap plus k cap. Very nice. Well, in that case, how we can deal with such kind of questions? We need to find out the gradient and we need to find out the dd, okay? So first we need to find out the gradient, so we need to operate it. This is the equation of the ls. So the examiner will give you the phi direct, because I have told you that phi is equals to plus minus f minus c bracket, right? So when you will get the final answer, you will get a plus minus. Sometimes the answer will be positive sometimes answer will be negative. It depends, actually it depends, but it's okay, no, not an issue, not an issue. So examiner will try to avoid this kind of problem, because when you will like attend any kind of competitive exams, in that case only one answer will be correct. Let's say answer is 4, your answer is 4, and the examiner will give you answer which is -4, then you have to correct the correct answer will be -4, right, not +4, because maybe you have taken the positive f minus c, and examiner took the minus, actually the negative f minus c, so it is very natural. So in multiple cases you will see examiner will try to avoid this problem, and he or she will give you this kind of question where phi is already mentioned. You don't need to subtract f, not f, actually c from f or something like that. So gradient will be del phi, right, del vector actually, but I have told you that multiple books like don't use this symbol. Why? I don't know why, but they don't use, their choice, something like that. So how we can deal with such kind of questions? We need to find out the dot product, not dot product actually, because phi is not a vector, it is a scalar point function, so it is not a dot product, it is a simple multiplication between vectors and scalars. Let's start with the vectors. So first of all we have to differentiate with respect to x, so it will be 3x square, wait a moment, 3x square y I cap plus 2yz k cap, not k cap, it's j cap, sorry, plus k cap. Simple, very simple. Now the point is given 1 comma 1 comma 1, so we need to put the point, because we have to find out the gradient at a particular point. Like we can't find the gradient in multiple points, so you need to find out the gradient at a particular point. So point is given 1 comma 1 comma 1, so it's very simple. 3 I cap plus 2 j cap, wait a moment, plus k cap. Well, very nice. This is our g, right? We need to find out the gradient now, no, not gradient, sorry, the dd. So how we can find out? It's very simple. We just need to do a simple dot product vector. Wait, now the thing is happening here, we need to find out the unit vector along m, and m is given something like that, right? So unit vector will be what is we have to divide it something like, divide it with 3 square plus 2 square plus 1 square, right? So it is very simple to understand, like this is 3 I cap plus 2 j cap plus k cap, right? If I'm not wrong, then it's correct. Okay, fine, that's correct. And this is also same, this is also same, so it's very easy to do. Maybe you can find out the cos theta, or basically I want to say, like you can find out the theta between the two vectors, which is a little bit lengthy calculation. So however, we will do a simple dot product. Now 3 squared is 9, 2 squared is 4, and 1 squared is 1, right? Hopefully my calculation is correct. 3 into 3 is 9, plus 2 into 2 is 4, right? Plus 1 into 1 is 1, divided by root over, what is that, 9 plus 4 plus 1. Both are same, we can say something like 9 plus 4 plus 1, and this is 4 plus 1, 5, 5 plus 9, 14. So this is the answer, this is the answer, and it hasn't any kind of units, be careful, okay? So this is the answer, very nice. Now the thing which is too much important, sometimes examiner will ask you find out the dd max, but he or she hasn't mentioned that you have to find out the dd max at a particular point. Let's say in that case the point is p, you don't need to find out the dd max at a particular point. In that case, how we can find out? In that case, you can't put the value like x equals to 1, y equals to 1, and z equals to, you need to calculate the dd from here. Here you have to do the dot product, and you can find out the dd, which is very complicated and very like uh, dangerous actually. No, I mean the dd will look like very dangerous. So however, this is about directional derivatives. Hopefully you can understand what is directional derivative and how can we find out. Basically it's a kind of projection of g or gradient. In case of gradient, we will deal with a kind of maximum rate of change of level surface at a particular direction, which is nothing but the normal direction or perpendicular direction to the level surface. In case of directional derivative, we have to find out the rate of change, not maximum, because maximum will be in the direction of normal or gradient. So however, you need to find out the dd max. Sorry, not dd max, actually I'm talking about directional derivative. So what is directional derivative? Directional derivative is a kind of rate of change at a particular direction, not in the perpendicular. Dd max will be in the direction of perpendicular, right? So dd max is a kind of generalized version of gradient, and gradient is a kind of special case of dd max. Hopefully you can understand now. Dd max is a, not dd max, actually dd is a or directional derivative or whatever. It is a kind of generalized version of gradient. When dd will be max, then it is equals to the magnitude of gradient, and the direction will be in the direction of the gradient. So hopefully you can understand. Very nice. So that's all for today. In the next video I will talk about curl or something like I will talk about some more examples, because when you will understand what is directional derivative, then examiner will try to play with the directions, like he or she will give you kind of a very complicated m, so that you can't calculate it easily. In that case you need to understand this condition or something like that. In the next video I will talk about some more examples so that you can understand what I mean. So that's all for today. Goodbye.